And with that, I will turn it over to Dr. Rai.
Thanks, Mikey. And it's really a great time to virtually meet our students. And all of you are welcome in the department. If I'm not incorrect, you are EE students. And we are happy to have you. I should say not on campus, but still in the department. But let me go ahead and tell you something about the programs in the department. We are part of computer science, or computer science and electrical engineering. These two are the combined departments. And now we call them as the School of Electrical Engineering and Computer Science. So in a way, it is nothing but 3 departments under the same umbrella. Electrical and computer engineering offer 2 programs, one electrical engineering and another computer engineering, and both are 127 hours credit programs. I don't know how many of you are familiar with that, but out of 127, about 39 are taken away by English, arts, humanities, social science, etc., etc. And between electrical and computer engineering, about 25 courses, means 70 to 75 hours are common, and rest of them are separate. So that's kind of a rough division between these 2 programs. There are different areas in the department: computer hardware, software, communications and signal processing, controls, electronics, electromagnetics, power, and then students are allowed to take multidisciplinary minors. We will talk about that. And also we have accelerated master's program, which if somebody wants to continue the undergrad program, can finish master's. Usually ideally it takes 4 + 2 years, but in that case, a person can finish in 5 years. So this slide basically talks about different areas in computer engineering: hardware, software, algorithms. These are the backbones. Then certain specializations like neural net and machine learning. I generally teach a course in this area, neural net and machine learning. Then we have another specialization like game theory and Internet of Things. You might be familiar with this. And here we have 2 human skulls or fragments, and it is shown that how they are analyzed using computer techniques. Communication and signal processing is an important topic or an important area in the department. And what we deal here is analog and digital communication, signal processing. And in that process, we also look into coding, encryption, data compression. And this is related to all kinds of data like audio, video, speech, and images. And here there is a typical example that how an original image, if we go for enhancing the image or make it a super resolution, it looks really a readable document. So we deal with the techniques for enhancing the images. This is just another example. On the top, we have a bitmap picture. In the bottom, we are having a JPEG picture. And some of you might be knowing that a bitmap file is very long. This one is 1.92 megabyte file. A JPEG file is quite small, 131 kilobyte file. But if you visually look into the quality of two pictures, it is very difficult to see the difference by just looking into the pictures. So obviously, it is important to know how the image compression means first saving a file into another format can compress the image, or you can use the techniques to compress the image. The other area is the controls, and controls is almost a backbone for manufacturing, chemical production, and refinery. And the most important thing that is used there is programmable logic controllers. A bunch of courses are offered in this area. And robotics, which again, we will discuss the minor later, uses this area. Mechanical engineering also use the control concepts. And here you can see that how the autonomous vehicles are shown in the picture, and they mainly use the controls as well as computers as well as electronics. Electromagnetics is another important area. You must have come across with radio frequency propagation, like your radio signal, AM, FM channels, TV channel. All of them are typical examples of radio frequency propagation. Microwave devices, most of you use the microwave oven. It is almost in every household. And wireless system, you all use Wi-Fi. So all these things are part of, under a broader umbrella, we can call them as electromagnetics. RFID and global positioning system is also part of that. And again, we are showing some measurements that students learn in different courses while dealing with this topic. Electronics is the backbone for devices. Any chip, whether it is a VLSI chip or a simple, smaller device, needs the concept of electronics. Now people are dealing with nano electronics, and all these courses are discussed, or all these topics are discussed in different courses in the department. We have a tools course, which is 2810. And here, a simple example is shown. The top picture is showing what circuit we want to put on PCB, which is exactly in the bottom, and what processes we use to go from circuit to PCB. So on both sides of these two pictures, we have shown the processes, and students actually do it in 2810 to develop the printed circuit boards. Power. There are three facets to power engineering: generation, how the power is going to be generated; once generated, how it is going to be distributed; and in that process, what are the techniques for power protection. So all these things are discussed in different courses, and also power electronics. Remember that any electronics that is used for power purposes have wide variation in voltage as well as in current. So they need a separate treatment. We have various multidisciplinary minors. Computer engineering students can take a minor in computer science, although electrical engineering can take two, but it is uh, quite easy for computer engineering students. And I have noticed that by since so many courses are common between the two, so a computer engineering student can take one extra course and get a minor in computer science. We also have a multidisciplinary minor in digital media with CCT. Robotics and technical cells are with College of Engineering, and energy minor with business school. So on top of 127 hours for the degree program, one can take, uh, let me put mathematically 127 plus X hours and complete both a major as well as a minor degree. And X is simply 1 or 0 if a computer engineering wants to take a minor in computer science. And as I mentioned earlier, we have accelerated master's program. This accelerated master's program helps those students who finish their BS degree from LSU. I'm from the department in LSU, and they can complete the master's program with 1 extra year. And all these down there are the links for these minors and the accelerated program. Digital media minor is through Avatar program. Avatar stands for arts, visualization, advanced technologies, and research. And this program is a multidisciplinary, and different departments participate in this program. Electrical is one, art is another, English, mass communication, music department, and also the parent department, that is CCT. Let's see what our students are doing. So here I have shown 3 projects. In senior year, every student goes through 6 hours of capstone design project. And these 3 are typical examples which our students have made over the years. This is not close to the actual one shown here, but at least it gives the idea how the real thing can be made to work. The students do participate in robotics competition. I'm sorry, this is an old picture, but the students of their own, obviously through IEEE, this is a society to which it is a voluntary society. Some of our students are very active and they participate of their own in a group project like robotics. They also do with other disciplines in formula cars and with EWB, that is Engineers Without Borders. The question is why you want to come for an engineering. And this is basically talking about average salary across various other disciplines in the university, like engineering, computer science, math and sciences, business, and so on and so forth. And you can see that engineers are paid little more as compared to others. This one is amongst various College of Engineering disciplines, and a computer engineering on an average is paid more than other disciplines. This one is basically talking about how the departmental computer and electrical engineers are paid as compared to national average, and the national average is basically from various colleges in the South. And it is also very competitive and comparable. Our students have joined various companies, and this table provides a list of some of the companies. They belong to things like IBM, Intel, CGI. These are in computer areas. L3 is also in computer areas. And also in the power area, I think Exxon, Dow, Intergy, I don't see it here. So they join different companies within Louisiana and outside Louisiana. Some of our students go for the graduate program, and they have been accepted again from different universities. That's it. Thanks.
Awesome. Thank you, Dr. Rai. Very informative presentation. I hope all of you guys were able to get some good info from all of that. We do have a couple of questions. Let me see. There was one from Miles. So he's an engineering undecided right now, and he knows he wants to go into the energy industry, but he's unsure of whether to go into electrical, mechanical, or chemical. So he was wondering what electrical engineers' roles are compared to other majors. Obviously, you can only really speak on electrical, but.
Right. I mean, again, an industry like Exxon hires from all the disciplines which you cited just now, because they need people from various branches. So it should basically depend on what his interest is. As compared to the other disciplines that you have just mentioned, electrical engineering is a little bit challenging because electrical and mechanical both are more math oriented to give the concepts as compared to other disciplines. And if the person you are referring to is going to take that challenge, then I should say electrical is the best.
Awesome. We have another question about Engineering Without Borders and how you go about joining these organizations. I have a couple of links that I'm going to put in the chat for you, Daniel, but I don't know if Dr. Rai, you have any information on how to join something like Engineers Without Borders.
Normally, I mean, since I'm new to this undergrad advising position, but based on my information, it is normally organized by the college, I guess. So Mikey will be in a better position.
Yeah, so it's not just an LSU thing. It's a nationwide thing, but LSU has its own kind of chapter, if you will. So I just put one link to the national organization in the chat, and then another to the LSU specific organization one. So that should have some contact info for Engineering Without Borders and some student leader information as well for getting in touch with those people. We have another question. What type of research is offered? This is from Daniel. He's extremely interested in participating in research in robotics.
This is a really good question because as part of our technical elective, a student is encouraged to take individual research in consultation with the faculty. So a student, of course, there is certain protocol to follow, but it is up to the individual faculty and the student's interest to do the research, and that will be counted as a technical elective. So this question is generally not touched by many students. I'm glad he asked this question. So yes, there is an option. Our program fits into that option, and a student is encouraged. All you have to do is just look into your interest, talk to the appropriate faculty, come out with a proposal, and follow the procedure.
Awesome. Hope that answered your question, Daniel. While you guys are thinking of any other questions to ask, I'll pitch one to you, Dr. Rai. What do you think makes a successful electrical or computer engineering student at LSU, or what can they do to be successful?
Actually, no, that's fine. This is so subjective. Means something that makes me successful may not be same as making somebody else successful. And again, it is across the generation too. Something that makes successful to one generation may not make successful to another generation. But there are some basic guidelines. Means whenever you study something, don't focus on that something only. Try to look into what are the other related things. Means instead of gathering information, try to gather the wisdom. And that is some people call as street smartness. So as long as you have the wisdom, no matter what you are doing, you are successful.
I'll kind of answer my own question because I was just in college a couple of years ago. I know all of you guys are coming to LSU and are about to have a great time in college, which you should. I would recommend definitely going to all of your classes. That first and foremost is the most important because if you miss class, you're going to miss important information for exams and such. So, and I also say get to know your professors as much as you can. They're there to help you and help you learn. So, especially in my latter college years when I was a junior and senior, I got to know my professors a lot. And even like to this day, I still talk to a couple of my professors now that I've graduated. And it's really good to get to know them because they're there to help you succeed. So that's just me answering my own question also.
That's great, Mikey. I was more philosophical and you are more practical.
That's okay though. We've got both in there. We have another question. I know this doesn't have to do necessarily with engineering, but how many of the fall classes will be online and will my lab classes be in person? Honestly, I don't think I know much more than you guys do. I think a lot of this is still kind of to be determined in the next week or two. So LSU will reach out to you with all of the information you need to know about things going online and things staying in person. Some things will probably change. I just don't have a great answer for you of exactly what is going to change. Dr. Rai, I'm not sure if you have any.
I think that it is still evolving, and whatever is decided by university, we all will follow eventually.
Yeah, it's definitely still evolving with coronavirus still evolving too, but LSU will reach out to you with everything you'll need to know. So I wouldn't worry too much. And at least everybody's in the same boat with all of these things going on. And you guys are definitely troopers for going through all of this during your transition to college, but I wouldn't worry about it too much. We have another question. What would you say is the hardest class in a computer engineering curriculum, Dr.
Rai? I will say that for some people, digital logic is hardest because you come out with a different concept. You have learned 1 + 1 is 2. In digital logic, it could be 1 + 1 is 0 or 1 + 1 is 1. So this is against the notion that we have learned so far. And it is not hard, it is just logic. But if you are tied up with the old notion that 1 + 1 always is 2, then it is a hard class. Otherwise, as soon as you come out of that zone, you will find that it is a very easy class.
Cool. Anybody have any other questions? Feel free to put them in the chat if you do. So we have another one. What language do you recommend learning? I know JavaScript and a little bit of Python.
Great. Java is also taught. as part of CSE. Let me go back a little bit. Electrical engineering students take one programming course. Computer engineering students, two programming courses. And there is no end to learning a language, just like human languages. I mean, most people are happy learning only English. Most people who have come from other countries, they know more than one language. So in computer area, knowing different languages are always good, but always there is a limit. So Java and Python, that's great. Most of my students use Python. They also use MATLAB in my neural net and machine learning course. But some computer engineering students are not some, but all of computer engineering students learn hardware description language too, because that's how you design a chip. So bottom line, as long as you know one, others are easy to follow.
Awesome, thank you for that. Another question, how much overlap is there between computer engineering and electrical engineering? And what are the differences between them?
I gave a rough idea in the beginning. Remember, both are 127 hours program. It is again mandated by state. So out of that, 39 hours are mandated again by state to go for AHS, Arts, Humanities, and Social Sciences. So whatever is left, 127 minus 39, is for electrical engineering and computer engineering. And since both are based on the similar concepts, both programs, so about 70 to 75 hours are common between the two. So add 39 plus that. And then the two streams deviate or change. We focus more on the computer science oriented courses, and they focus more on the power and control related courses.
Great, and I'm also writing this out in the chat right now. I'm dropping a link to for the flowcharts for each of computer engineering and electrical engineering. And the flowcharts will have all of the classes listed, color-coded, that you'll be taking for each major throughout your 4 years. So obviously you can switch up your schedule a little bit compared to what it's given on the flowchart, but that will have all of the classes you'd be taking with each major, so you can kind of see where the classes vary and where they differ. So
I'm glad, Mike, you mentioned the flowchart. I was missing this information. In the first, second, and third semester, most of the courses, or almost all the courses, are common between electrical engineering and computer.
yes, and we have another question. When describing digital logic, do you learn about the different types of logic gates in that class?
Yes, that is a very basic or fundamental thing. You not only learn combinational, these are combinational logic gates. Means remember that anything with or without memory. Without memory is combinational, with memory is sequential. So you have to learn both. So you not only learn both combinational and sequential, but also learn how to design small circuits or small digital logic circuits, not fabricate it, but design it.
Yeah, good question. Any other questions from anyone? While you guys might be thinking of one last question, I'm going to put my contact info in the chat. So if you have any other questions that you forgot to ask, feel free to shoot me an email, and I can forward it along to Dr. Rai afterwards as well. So I'm just going to put my contact info here in the chat. If nobody has anything else, that can wrap it up. Dr. Rai, do you have anything else to add?
Again, I really appreciate that they joined us. They are really interested in knowing a little bit more about the department, and I hope I provided some answers, and you have given your contact information. If they come out with some additional question, we will try to provide the answer. We don't claim that we know everything, but still, we will try to help you with the answers. Thanks very much.
Yeah, thank you guys for signing on. And like I said, this will be posted online since it was recorded, so you can go back and watch it if you need to. And so just keep a lookout for that. I want to thank Dr. Rai for making this presentation. It was very informative. Even if just one thing helped you guys, it was worth it. And we're definitely very excited to have you guys come in here in the fall. Like I said, circumstances aren't perfect, but we're going to all make it work, and we're super excited to have you guys on campus. So thank you, Dr. Rai, and thank you all for joining. And as always, go Tigers.
Thanks, Mike.